My name is Amira binti Omar and I will explain about the introduction. Sound waves travel until they hit something and are reflected back. The echoed sound wave is received by the transducer. The echo's amplitude may be lower than the pings, but the carrier frequency should remain the same. When determining the speed of sound in air, an external timer is used to record the time of flight, which means the time it takes for sound waves to travel and from the object, which can then be converted to distance. As they move from the transducer, the transmitted sound waves expand out even further. To put in another way, sound waves travel in the shape of a cone angle from the transducer. Next, I will explain about the objective of this study: to develop an automatic distance measurement device using Arduino Mega. Second, to understand the function and control of each electronic component and how it is integrated into the automatic system measurement device. The last one is to explore programming of the automatic system measurement device using basic Arduino programming language. There are three scopes of this study. The first one is the system used in this project is Mega Arduino. The second one is the volt was set to 5 voltan. The third one is output of the system is the distance in centimeter and inches. There are few components that has been used in this project. The components are Mega Arduino, ultrasonic sensor, breadboard, male to female wire set, LED, and the last one is LCD.
Assalamualaikum warahmatullahi wabarakatuh. So today I will be presenting real life application for our lab group, which is distance measurement. So the real life application for distance measurement is automotive, in automotive industry and construction industries. So in automotive industries, the distance measurement is mainly used in automotive sector. Usually it is installed in a vehicle and act as a parking sensor. The distance measurement device or sensor usually have tolerance in distance to give out warning for parking sensor. Therefore, the distance is measured and then it is converted into an alarm to give out warning for parking. Okay, next, for construction, distance measurement also is used in construction sector. It is installed in some measuring device which is used to measure the distance from one point to one point. Its application is when it gave out distance measurement in a reading when the sensor of the measurement hit an obstacle. So distance measurement have many application in real life. Okay, that's all. Thank you.
Assalamualaikum, my name is Shafiq bin Hamidan and I'm going to continue explaining the procedure that has been done in this experiment. So the procedure number 1, the ultrasonic sensor is mounted to the breadboard. Number 2, by using a red wire, connect the red wire at the same row of the VCC of ultrasonic sensor at the breadboard. At the other end of the wire, connect it to the 5 volt section in the Arduino Mega. Number 3, by using a orange color wire, connect it to the parallel to the red wire 5 volt. For the other end of the wire, connect it to the VCC of the LCD screen. Number 4, by referencing the black wire, connect it to the breadboard that is aligned to the GND, which is ground at the ultrasonic sensor. Then, connect it the other end of the same black wire to the ground in the Arduino Mega. Number 5, using other black wire, connect it to the breadboard that is on the same line of the ground of ultrasonic sensor. At the end of the same wire, connect it to the ground at the LCD. Number 6, connect the trick at the ultrasonic sensor to the pin 12 at Arduino Mega. Number 7, using a green wire, connect it to the echo of the ultrasonic sensor to the pin 13 at the Arduino Mega. Step number 8. Now, connect the SBA and SCL from the LCD to the pin that is labeled the same at the Arduino Mega. With that, now we already complete the assembly of the project. The complete assembly of the project should look identical as the figure show. Now, all we have to do is to connect the Arduino Mega to the computer and ready to upload the code. After the code has been uploaded, the whole project should be run with the expected result.
Assalamualaikum warahmatullahi wabarakatuh and good day to all. My name is Ain Shakila binti Azizur Rahman. Now I will share with you regarding the discussion of this distance measuring system project. Few things will be discussed in this part of video, including the system design, the prototype model, the results of the simulation, and also the problem faced throughout this project. The first one is the system design. System design will explain the process in making this project a success, which first we will need to find the coding of this system, distance measuring system. The coding can be obtained through online or any other sources. Up next, when we have the code already, we need to transfer it to the Arduino IDE system by connecting the Megaboard to the laptop also. And when the coding is transferred to the IDE software, we will again transfer the coding to the Arduino Megaboard and connect all the sensor lights wires to the breadboard. After connecting all the components, we will then run the system, and in this case we also already have the input sources from the laptop, or any other input sources that can be obtained is the power bank. Up next, when all the system is connected completely, we will check the output, which in this case will be the distance in centimeters and also in inches, followed by the prototype model of this distance measuring system. This is the prototype model that have been done by our group. Few components have been used in order to make this project a complete one, which include the power bank as an input sources, the USB wire, the Arduino Mega board itself, the LCD display which will displaying the output in centimeter in inches, the connecting wires, the breadboard, the LED orange, the ultrasonic sensor to measure the object, and lastly an object to be measured, which in this case we are using the spectacles as an experimental object. The result of this project is measured in two different methods, which is measuring an object by manually or also measuring it by using the system itself. The video of how the system will run will be shown by Ame, and in this part we are comparing the result by looking at the display on LCD display. It shows that the object is 7.59 centimeter from the ultrasonic sensor, and by measuring it manually, it is about 7.5 cm, and it could be concluded that the measuring system is accurate. Lastly, the problem faced throughout this project is discussed in this part, which have two major problems that we have been facing. The first one is when trying to apply LED to light up in the system. We are having the problem as the first LED that have been installed blow up. I don't know whether it is one of the major problem because of the current, that strong current or what, but lastly we managed to light up the orange LED as a sensor of the system, which when it lights up, that means the system is on. Next is a problem that have been facing is that we couldn't find the appropriate coding terms, as too many coding and terms in an Arduino IDE software library. So it requires quite a lot of time to find the correct one for each type of components. And that's all from me. Thank you.
Next, we will go through the conclusion. Therefore, the ultrasonic sensor is the foundation of this project. It offers practical exposure to an ultrasonic sensor that is used for object identification, finding, and avoidance. It is tested to see how sensitive the sensor is when detecting distance. We could identify measurement errors, resolution, and sensitivity during the project testing. Several mistakes were made while carrying out the experiment. It might be the result of instrumental error. For instance, the Arduino Mega has been in use for a long time and may give an inaccurate result when attempting to monitor the voltage. Lastly, human error can also play a role in this. Our team member might make a mistake during the coding, which would result in the sensor reporting an error.